Hi everyone, I hope you had a good weekend. We're going to start our new learning target this week, which is adding and subtracting rational expressions. So before we start to add and subtract, we are going to review some rules for fractions. So you need a common denominator to add or subtract fractions. And remember, when you do add and subtract them, you only combine the numerators, the denominators don't change. So let's review with just some basic problems here that, back from elementary school. So when you check, obviously they don't have common denominator. So you ask yourself, what's the smallest number that both 7 and 3 divide into? The least common multiple of the two of them. And the smallest one is 21. So what you're going to do is take each fraction, and you're going to ask yourself, how do I make 7 into 21? Well, you multiply it by 3. And remember, whatever you do in the numerator, whatever you do in the denominator, you have to do to the numerator. So your first fraction will turn into 9 over 21. And then we're going to do the same thing with our 2/3. So again, I'm going to ask myself, what do we multiply 3 by to make it into 21? And it's 7. So top and bottom, we multiply by 7. And then down here, 14 in the numerator and 21 in the denominator. And once you have them matching, again, we only add the numerator. And you get your final answer here. Again, just leave it as an improper fraction. That's fine for now. And that's it. All right, let's try the next one. Okay, so here we have 7/10 and 8/5. So we're looking only at the denominators to start with. They don't match. But notice for this one, 5 does divide into 10. So we don't have to change this first fraction, only this 5. So we're going to take our 8/5 and we're going to ask ourselves, 5 multiplies by what number to make 10? And that's 2. So top and bottom, we multiply by 2. So we're going to repeat my 7/10 here, and then I get my 16 and 10. Again, we only combine the numerator. So this one again we're adding, so 23 over 10. Okay, let's try one more. Now we're going to do one with subtraction. Okay, so again for this one, just like the last one, 4 does divide into 28. So we know that it's going to go in 7 times, so that's the number we're going to use. So let's only change our negative, our 1/4 here. Again, top and bottom, we multiply. This is a subtraction, so only subtracting the numerators, -4 over 28. Now this one, notice, unlike the other two we did, it can be reduced, so we will go ahead and reduce it just because you can. It has a GCF of 4. So I can take that out by dividing it out, and that's what you get. All right, so that is adding and subtracting just with regular numbers. So now we're going to add and subtract with rational. So you can see here we have a polynomial on the bottom. Now we're going to start with ones that have the same denominator. So these are going to be a little bit easier. If you notice they have the same denominator, just look at the numerator and add them together. So 7 plus 3 is 10 over 4x. And that's it. So once you're here, though, you do want to check if you can simplify any further. So I see that 10 and 4 have a common factor of 2, so I'm going to divide a 2 out of each one to get 5 over 2x. And that's the simplified form. Okay. All right, same thing over here. Watch with your subtraction. This one's not bad because we only have one term. You will need to distribute if you have more than one term, but this one's not bad. We only need to combine 2x minus 5, not like terms, so you can't put them together. And then we check for any reduction, any reducing we can do, and there's nothing that they have in common. Remember, these are terms. You can't reduce. These are connected together. So only if it's in factored form. Okay, so adding and subtracting with the same denominator, really not so bad. It's when they don't match. So let's go ahead and take a look at that. So first thing we're going to do is looking at finding the least common denominator, because it's a little different than the first problems when we have variables. So to find the least common denominator, we're going to practice finding the least common multiple, the LCM. Okay, so let's start with the 2 here. Okay, so we have 4x squared minus 16, 6x squared minus 24x plus 24. So we're going to factor each polynomial. So just like you did for simplifying, factoring the polynomials. So I'm going to start with this one here. I see it has a 4 that can come out. So I'm going to start with that. You're going to get x squared minus 4 when you divide everything here by 4. Now you should notice that this is a difference of squares. So we can go one more step. Oops, I'm going to put a 2. And factor that. So that is the completely factored form of that given expression there. All right, so let's go ahead and factor this. Now you should see that all three of these terms have a common factor of 6. So we're going to start by taking that out. And that leaves me with my trinomial. It's a quadratic and my a is 1. So you should be able to quickly factor it, finding the two numbers that multiply to positive 4 and add to negative 4. Those two numbers are both negative 2. Okay, so we don't want to simplify. What we want to do is we want these to match. And so you should see right now that they don't. Okay. What we have here, well, first we have a 4 and a 6. Those obviously don't match. So you want to ask yourself, what's the least common number that 4 and 6 divide into? And that number is 12. So you're going to have to make this into a 12 and this into a 12. Okay. And you would do that by multiplying them both by 2. So we'll make a little note here. We're going to need to multiply by. Okay. And then I see I have one group in both of an x minus 2. So I'm going to leave that. Now here I see I have an x plus 2. I don't have an x plus 2. So over here, okay, we're going to do a couple things. We're going to multiply by. And we're going to have to multiply by x plus 2, so we have one here. Okay. And then lastly, when I come back over here, this one has two groups of x minus 2, and this one only has one. So I'm going to have to multiply this one by an x minus 2. Okay. So we're going to take our factored form, we're going to multiply by 2, so that's going to turn into an 8. And I'm going to add an extra factor. So, sorry, I meant to make that a 3. I apologize, because that doesn't make it 12. 4 times 3 gives us 12. And then we'll have an x minus 2, x plus 2, x minus 2. Okay. Here, if I multiply by 2, we get a 12. Again, x minus 2, x minus 2, and then the x plus 2 from this one. And now you can see they match. The order doesn't matter because it's multiplication. What matters is that the numbers match here and any of the factors match. Okay? And so the least, you only need one of them. I was just showing you how to find it because when we do the denominators next, we will have two sets that match. Okay? All right, so we're going to get to the back side. I'm going to go ahead and stop here and flip.